Now example 2. So example 2. What are the excuse me, absolute max and absolute min of f of x is equal to x plus 4 sine x on 0 to 2 pi. Okay, well, let's go ahead and take f prime. So f prime of x is equal to 1 plus 4 times the cosine of x, and we set that equal to 0 because our first step is to find the critical values of this function. Critical values, we take the derivative and we set it equal to 0. Excuse me. So I've got cosine of x is equal to 1/4. That means that x is equal to the inverse cosine of 1/4, or 0.25. And on the interval from 0 to 2 pi, I find that x is equal to 1.82 radians, or 104.5 degrees if you prefer degrees. Or we have 4.46 radian, or 255, I'm sorry, this is going to be negative 1/4, 255.5 degrees. Okay, so these are our critical values. Now we want to evaluate f at those critical values. That's our second step. So f of 1.82 is equal to 5.70. In other words, I put these back into the original function to evaluate it. And f of 4.46 is equal to 0.59. Now I'm going to evaluate at the endpoints 0 and 2 pi. So f of 0 is equal to 0, and f of 2 pi, well, that actually equals 2 pi, which equals 6.28. So now I have 5.7, 0.59, 0, and 6.28. The absolute max is the biggest number among these. So the absolute max is equal to 6.28, and that happens, the absolute max happens at x equals 2 pi. The absolute min value, well, that is going to be, the smallest number here is 0, and that happens at x equals 0. That is all. Find the critical values, evaluate the function at the critical values, evaluate the function at the endpoints, pick the biggest, pick the smallest. You're done. Let's see what this looks like. So here is the function. This right here is your f of x, and I decided to go ahead and draw the derivative on there too. This is f prime. Okay. So this f of x here, this is the x plus 4 sine x, and this f prime of x, this is equal to 1 plus 4 times the cosine of x. So that's it. You know, it achieves its maximum value at, you know, whatever it happened to be, which was 2 pi, I think, and its minimum at 0, and there you go. That's it. Over the domain, you're done. So 2 pi would put you about 6.28, 5.25, so somewhere around here. And sure enough, that is the highest value because we're looking at that. And this is going to be the lowest value. That is all. We had the critical values where the derivative equals 0. So those were here and here. In other words, whatever that was, the 1.82 and I think the 4.46, those are local maxes and min. Local max, local min, but they're not absolute max and absolute min. So we have to include the endpoint, and in this particular case, it's the endpoints at which this function achieves its absolute values, its extreme values. Okay, thank you so much for joining us here at Educator.com. We'll see you next time so that we can do some example problems with maximum and minimum values. Take care.